Hello everyone, welcome to my channel Engineering Studies. We have already started analog circuit series, right? So we have seen one lecture on it. So just brief introduction we have seen in that lecture. The second lecture is based on diode circuits. Okay, so let us start with the introduction of diode. So diode is simplest and very fundamental non-linear circuit element. Okay, non-linear means what? That is current and voltage do not follow each other. That is current do not follow voltage or voltage do not follow current. Okay. Also the diode is two terminal device. It has two terminals. While seeing its symbol, we are going to see the more details of it. Okay. And also it has nonlinear current voltage characteristics, the same thing. Okay. Now let us see the diode circuits, DC analysis and its models. Okay, so what we are going to consider here, we are going to consider an ideal diode to understand its terminals, symbol, everything and its working also. Okay, so we have seen already that the diode has two terminals. Okay, so one terminal is known as anode and the other terminal is known as cathode. Okay, so if we compare it, it will seem like a arrow structure. Okay, so so this part will known as cathode and the other part is known as anode. That is, the tip of the arrow will be called as cathode and the other part will be called as anode. Okay, and here we will have voltage and current will flow from anode to cathode. So current will always flow in one direction only, therefore it is also known as unidirectional element. Okay, now the analysis of nonlinear electronic circuit is not a straightforward, but there are some electronic functions that can be implemented only by using nonlinear circuits. So the examples are like generation of DC voltage from sinusoidal voltage. It will require nonlinear circuit only, and also implementation of logic functions. Okay, so there nonlinear circuits can be used. Okay, now let us see the current voltage characteristics. So we can see on x-axis the voltage is plotted and on y-axis current is plotted. So this part is reserved for forward bias and this part is reserved for reverse bias. Okay, so for ideal diode, these are the characteristics. Okay, so in forward bias, what we will get? We will get zero voltage, but maximum current. And in reverse bias, we will get maximum voltage, but zero current. Okay. Now let us see some terminal characteristics. Okay. So what will happen if we will apply a negative voltage? So the current will not flow through it, right? And the circuit will behave as open circuit. Okay, so whenever this condition will be held, the diode is said to be in reverse biased. So same thing we have written here. When the voltage is less than zero, that is when the voltage is negative, the current value will be zero. Okay, so the diode will behave as open circuit. Fine. What will happen if we will apply a zero voltage to the diode? That is, positive current is applied to it, then what will happen? We will get a zero voltage drop across the diode. So current is maximum and voltage is zero. Okay, so ideal diode will behave like a short circuit or forward bias. Okay, so the ideal diode will be in short circuit in forward direction. Okay, now let us understand this in more detail by considering the example. So in this example, in this figure, we can see that the voltage applied is 10 volt and one resistor is fixed here, which is of 1 kilo ohm rating. Fine. Uh, we can see the diode is forward biased because positive terminal is applied to anode and negative voltage is applied to cathode, right? So this diode is now in conducting state. Therefore, the voltage drop will be zero because we have seen already that is in conducting state, the voltage across the diode for the ideal diode will be always 0 volt. Okay, so we do have voltage value, we do have resistor value, so we can easily find out its current value, right? Because we know the relationship between voltage, current and resistor, that is I is equal to V upon R. So V is what, 10 volt, and R is what, 1 kilo ohm. So current across it will be 10 milliampere. Okay, fine. Now let us understand the another example. So here we can see the 10 volt voltage is applied here, and the current is 0 milliampere, and the resistor is again 1 kilo ohm value. If we will carefully observe this, the negative value is applied to anode and a positive value is applied to cathode. That means that the diode is in cut-off state. That is, diode is reversed biased. Therefore, whenever the diode is in reverse bias, the current is 0. Yes. Therefore, the entire 10 voltage will be appeared here. Will be appeared here. That is across diode. Okay. So the same thing is written here, that 10 volt supply appear across a reverse biased diode. Fine. So for this lecture, we are going to stop here. In the next lecture, we are going to see load line analysis and some diode configuration. That's it for today. Thank you so much. Please like, share and subscribe.